Hi guys, this is the first video of our integration video series. We're going to be looking at all the different types of integration techniques, and we're also going to be looking at some more difficult integration questions which could possibly come up in the exam. So first things first, I've laid out here a couple of the standard integration rules for certain functions such as e to the x, we have 1 over x, and so on, and all the trig ones. So what you can think of is that integration is actually the reverse of differentiation. So you can see that some of the integration functions seem similar to the differentiation rules that we've learned previously. Right, unfortunately for us, this is not actually in the formula block here, so you're going to have to try and memorize these all and just get used to it, because eventually you want to be able to integrate all different types of functions if they give it to you, right? So if I was to ask you, let's say I want to integrate e to the x plus 3x squared minus 4 sec x tan x. Well, we just have to look at each individual one separately. So you can see from e to the x, well, if we're to integrate that, I'll just e to the x. 3x squared, hopefully we know to this one, this is x cubed. And sec x tan x, well, that turns into sec x, so just leave us with 4 sec x. And don't forget the plus c constant as well this. So as you can see, it's not too difficult, it's just a matter of being very familiar with what integrates to what. So this part should be relatively simple, but if I were to now ask you to integrate e to the 2x, like so. Right, so as we said, if integration is actually the opposite or the reverse of differentiation, right? So if I asked you, how do you differentiate e to the 2x? Well, we've learned that if we were to differentiate this, we differentiate the function to bring it to the front and then write it as e to the 2x. So if this integration is the reverse, what I have to do now is rather than multiplying by the 2, I actually divide by the 2. So in fact, if we're to integrate e to the 2x, it would be 1 over 2 e to the 2x plus c. This rule applies to all the different standard functions we've shown below. So if I was to rewrite, let's say cos x, and I'm going to write it as f of x inside the angle like this, then this will turn into 1 over the derivative sine f of x like this. Okay, so this way we can integrate all different types of functions. Another example, let's say I want to integrate, let's go for 2 sec squared 4x plus 1 over 2 cosec squared 5x plus e to the 3x dx. Okay, so step by step we just integrate it as we would do. So 2, remember there's a 4 inside here, so rather than multiplying 4, which we used to do for differentiation, we are now divided by 4. So 2 over 4 times sec squared goes to, if you look at the table, tan, so it'd be tan, and the function remains as 4x, plus 1 over 2 times cosec is 5 again, so you multiply by 1 over 5 or divided by 5, and our cosec goes to negative, so it'd be a negative cot 5x plus divided by 3 e to the 3x plus c, and then we can just simplify it. So whenever there's a function inside a function, then we have to divide the derivative of that function when we're actually integrating. Let's try some more examples. So let's say I want to now integrate 1 over 2x plus, let's go for 5 sine 4x dx. Okay, so as you can see, 1 over 2x, I can split that up into 1 over 2 times 1 over x like this, plus 5 sine 4x, because 1 over 2, when we integrate 1 over x, we get ln x, right? So this would be actually 1 over 2 ln x, like this. Just be careful, this does not become ln 2x when you integrate x. Okay, so this is the wrong way. There are some students who make this mistake, so it's a very common mistake. Just be aware that it's not, we split it up as we go along. Plus, it's divided by 4, 5 over 4 cos 4x. And as you can see from the list, sine actually goes to negative cos, so this should be a negative value like this, plus the c here. So as you can see, as long as we are very familiar with these like 9 rules, 9 ways of integrating the standard functions, then we can just about integrate most functions which we are given. So this is the first video just introducing you to the basic functions. We're now going to be looking at using or integrating more difficult trigonometric functions in the next video.